Sorry, I was interrupted by a call. Let's continue. So, we're talking about that we want to prove NCHA is a parallelogram, right? So we already know that NC is in parallel with AH. The next thing we want to prove is that AN is in parallel with HC, then NCHA is a parallelogram, right? To prove AN is in parallel with HC, we can just prove angle NAC equals to angle HCA, right? And we already know that angle NAC equals to angle NBC, right? And the angle HCA, can be translated to this angle, HD. We actually call this point as E, right? So it's A equals to angle HDE, right? And in the previous improvement, we demonstrated that HDE can be translated to the angle ABE, right? So we just need to prove that angle ABE equals to angle CBN, right? That's why we have these equations here. I just want to review that angle HBA, which means EBA, plus angle BAC equals to 90 degree, and angle CBN plus angle BNC equals to 90 degree. And because angle BNC equals to angle BAC, then we get that HBA equals to angle CBN, which means angle HCA equals to angle CAN, which means HC is in parallel with AN, right? And from here we know that CNAH is parallelogram, right? So it's a parallelogram, and because it's a parallelogram, so we know CN equals to AH, right? So we just prove that CN equals to AH, and we already know that from here, or from here, right? Let's look at here. The CN, actually from here, CN is twice of OR, right? And CN equals to AH, which means AH is twice of OR, right? So we just prove that AH to OR equals to 2. And then we know because triangle ORM is similar to triangle HAM, so AM, this one, to MR equals to 2, right? Because AR is median on edge BC, and we know that AM to MR equals to 2, which means M is a centroid, right? We can rewrite it as G. So based on all of this, we just prove that O, V, G, H are collinear, right? And now we want to prove OG to GH equals to 1 to 2, GV to VH equals to 1 to 3. This would be very easy to do, right? Because we know that, let's just draw a line here, right? Represent for O to H. And V, that's the center of 9-point circle, is the midpoint of OH. And we have another point, centroid G, right? right? We already know that Hg2 GO equals to 2, right? And HV2 VO equals to 1, right? And let's see, we want to prove that OG to GH equals to 1 to 2. OG to GH equals to 1 to 2. That's already been proved, right? GO to HG equals to 1 to 2. Now we want to prove that GV to VH equals to 1 to 3. GV to VH equals, okay, so we want to find the GV to VH, right? VH equals to VO, right? And we want to find the GV. GV can be calculated as OV minus OG, right? So let's do this. GV equals to OV minus OG, right? And we want to find the GV to VH equals to GV to OV equals to OV minus OG to OV equals to OV to OV, that's 1, right? Minus OG to OV, right? Equals to 1 minus OG to OH divided by 2, which means twice of OG divided by OH, right? And OG to OH, twice of OG to OH is OG plus GH, right? And we already know that OG to HG is 1 to 2, so which means that HG can be written as twice of GO, so that's equals to 1 minus 2 OG divided by OG plus 2 OG, right? So that's equals to 1 minus 2 to 3 equals to 1 to 3. 1 to 3, right? Okay, we just finished all the improvement. Let's do a short review. For the 9-point circle, we just proved that the fit of 3 altitudes, the midpoint, and the midpoint on each edge, and also the midpoint from also center to the vertices. These 9 points are on the same circle, and the center is a midpoint from the centroid to the circumcenter, right? And the radius would be the half, just because that the midpoint triangle, the sizing of that the midpoint triangle is half of the triangle ABC, right? And then we just figure out that centroid, circumcenter, and orthocenter, they're on the same line, they're collinear, and also the midpoint of the OH, that's the 9-point circle center, is on these 4 points are collinear, right? And then we find the ratio. Basically, that's it. That's a property of the 9-point circle. We will talk more about how to use this theorem and how to solve the problem related to it in the future videos. I hope you like this one. Thank you. See you in next one.